the cognitive architecture is very, very important. I mean, it's just as important as the infrastructure. And I'm skipping it over here just because it's not the focus, not because it's not important. In terms of deep neural nets, I do think they have a big role to play. I think backpropagation is probably got to die for us to get to AGI, because backprop doesn't do continual learning. So there's a lot of other ways to train deep neural nets. None of them has been scaled up to the level of backprop. I think they will be in the next couple of years. I mean, one is predictive coding, which is a long history. Causal coding is my own invention, improvising on predictive coding. But these are purely local learning methods, right? And there's an important thing here in terms of decentralization, because with predictive coding, like each neuron does its own learning, and then the whole network self-organizes, sort of more like a Hopfield network in a way than like a backprop network. Now, actually, one of the things that incited me to come to this conference was seeing that Reza had given a talk on fluidic neural networks. Now, I wrote a paper on this last year. You can take the Bellman equation, underlying reinforcement learning, and it maps by an interesting one-to-one transformation into the Navier-Stokes equation, underlying fluid dynamics. So you can actually make an alternate kind of neural net evolves by fluid dynamic equations, right? And there's pluses and minuses to that. That could be a whole talk or symposium or something. But the point is, as well as there being other things besides neural nets, there's other ways to train neural nets besides backpropagation. And backprop doesn't work for continual learning, right? And this is something I can't believe that big companies are not paying more attention to, this very large problem, right? This is why we have these models like, 5.2, 4.0, right? Because you train the thing, then you have to freeze it and do inference. But I mean, that's not how the brain works, and it's not how an AGI should work. And it's the limitations of backprop as a learning algorithm, not really the limitations of formal neural nets as a data structure. And it is bizarre to me that the whole AI industry is so locked into backprop as a learning algorithm. There's not huge research programs aimed at better learning algorithms. So I mean, we're within my AI research team at SingularityNet, our decentralized platform project. I mean, we're working on the Hyperon neural symbolic evolutionary knowledge metagraph approach. We also have a team working on predictive and causal coding as decentralized approaches, right? So, I mean, Kwaai is doing with decentralizing training of backprop-based neural models is great. It can become even greater if you have a more decentralization-friendly neural infrastructure, right? And that brings me to this next point: is decentralized infrastructure is another important part of the whole thing, right? I mean, you totally want AI methods that are AGI worthy, but you want AGI worthy methods that are amenable to decentralized learning also. And then you need a whole bunch of high class plumbing to allow the decentralized learning to work. And Kwaai has some pieces of this which are very nice. I think in SingularityNet and ASI Alliance, we have some other pieces of this that are nice. And I think these can be combined together in various interesting ways. And seeing all this horrible mess in Iran that our great leader Trump is orchestrating now, I mean, it made me reflect on how energy wars and AGI wars intersect. And I won't divert the next 5 minutes of the talk onto this, but I would say that centralizing AGI in a few huge hyperscaler server farms pushes to centralize energy in a few locations, which makes geopolitics even nastier than it would be otherwise. And if AI were decentralized, its use of energy could be decentralized, which makes less of a nasty synergy between AGI wars and energy wars, right? So there's a lot of reasons why decentralized infrastructure is important. And I think one thing I'm hoping to see this year is to get a positive flywheel with our Hyperon proto-AGI stuff, where we're using our Hyperon tools to help develop the next generation of Hyperon tools. Because we do see that with LLMs now, right? Like, we're all using LLMs to help code, and you can use LLMs to help code better LLMs. So if you have something smarter than LLMs, and you can use that to help improve the thing to make it even smarter than LLMs, right? I mean, then that's a sort of flywheel that could make AGI come in 2027 or whatever, right?